Hey, what's up guys? Welcome back to another video. We're going to continue on with piecewise functions. This is part 2. So in the previous piecewise functions video, we learned about what they are and how to evaluate them. And in this one, we're going to learn how to graph and write them. So right here, on the right side, I have a graph, and then I have written out the piecewise function. So now we just need to graph it. So it's always good to graph from left to right. And what I like to do is to try and envision where my domain is, or where where these functions are excuse me, on the x-axis. So the top function that we have here will cover all negative numbers, so it will cover everything on the left side. And then the right function right here is all the positive numbers, so it will cover everything over here. So that's where I know that my function is going to stop and start. So let's start with the top one. Let's just graph it out. So y equals negative x minus 4. Well, we know that the y-intercept will be at negative 4 right here. Now I just have to ask you right there, is it going to be an open or a closed circle? If you remember from last time. Well, right here it says less than but not equal to. So we are actually going to have an open circle right here. Now we're going to graph to the left of this because it says that this function exists for our negative numbers. Excuse me. And so now the slope right here is a negative slope and a -1 slope. So that means it's going to go up 1 and over 1, up 1 and over 1. So just going to be a straight line right here in this direction, should cross at -4 on the x-axis like that. Just like that. Okay, so now let's go to, say, y equals x. Well, we all know what that looks like, but this is for our positive values. So at 0, it's going to start right there, and we're going to have a closed circle because this is greater than or equal to. Just like that. So we just graphed our piecewise function. And so here's a list of questions that kind of help you understand how to graph and what are important pieces to know when you are graphing. So what is the domain of the left function? When I say left, I basically just mean the functions that are over this way. So you want to try and identify where they will exist to. We've just been kind of getting lucky with our functions, and all of our functions have stopped and end right here on the y-axis when x is 0. So it's not always going to be that case. Sometimes you're going to have functions that exist maybe to here, and then you might have 3 functions where it looks like this, and then like this, and then like this, or something like that, you know? So identify where the x values exist, and then go from there, because then you know where to draw it to, and graph left to right. Usually you'll see these piecewise functions written out where this is the far left and then the bottom one is the far right, and they kind of go in that order. And then you have to identify where your open and closed circles are, just like we did. And then we determined the domain the domain on the right, and we determined that it was a closed circle. And then now we still need to answer what is the range of our function. So this one's a bit weird. So both of these functions right here go up this way right there. So pretty much, even though this function right here only exists to right here, well, this function starts down here and then goes upwards, right? And so our range exists all the way up until that -4. So the range of our function starts at -4. And excuse me, guys. It starts at -4, but is -4 included? And you can see that we have a open circle, so no, it is not. So we have to write a parenthesis instead of a bracket. So -4 to infinity. There you go. So here, I'm just going to go ahead and highlight that. We had closed, and this one was open. And this one was -infinity to 0. This one was 0 to infinity. And this one is a bracket right here because the domain on the right, so the right function right here that existed for the positive numbers, it was closed right there, so we have a bracket. So that's how you graph. Just take it step by step, look at each piece of your piecewise function, graph it, and then you kind of have to like truncate it where it doesn't exist and where it does. So now how do you write piecewise functions? So let's go ahead, and I kind of showed you in the last video, so this shouldn't be that hard. But we have to first identify what both our functions are, and then we can determine the range or where they exist on the graph. So let's talk about this one right here. Let's identify that line. So what is the slope of that line right there? And the y-intercept? Well, you can see here that it crosses at -3 right there and +3 on the y right there. So that's going to be a rise of 3 and a run of 3 in a positive direction. So a rise of 3, run of 3, which means that it's just going to be 1. Our slope is 1. Because our rise is 3, run is 3. 3 divided by 3 is 1. Our b, we already identified that it crosses at 3 on the y-axis, so our b is 3. So our function is f of x is equal to x plus 3. Now, do we have an open or a closed circle? We have a open circle right there. So, it is an open circle. And what does this mean? We talked about it more in the last video. But what that means is that 3, the value of 3 right here, will not be included in our set. Because when x is 0, it will equal -1 down here, not 3 up here. So this means that this means that the value uh, 3 on the y-axis, that the value is not included. So when we write our piecewise function, how do we show this in an equation? We're going to show this as a less than, because our function exists for the negative numbers for this one right there, going less than, and we don't show equal to. Alright, now let's go over this one right here. Oops. This one right here. So what is the slope right there? So let's try and see. So I think how I have it drawn is that it cuts through right there at the point 1, 1. And you can see that right here we're at 0, -1. So we have to go up 2 and over 1. So up 2 and over 1. So our m is equal to 2 over 1, which is equal to 2. And b is equal to -1. That is where the y-intercept is. So our function, f of x, is equal to 2x minus 1. Now, is it an open or a closed circle? It is closed. And so this means that the value is included. And so to show that in an equation, we would say greater than or equal to, just like that. So let's write all that we have and compose our piecewise function. So we write f of x, right? We say is equal to, and we use this sign right here to whenever we're going to show multiple functions in a piecewise function. So let's write the function that exists from negative infinity to 0 that we showed, so the less than part. So that was f of x plus 3. F of x is equal to x plus 3. So x plus 3, write a comma, and we say if, right here, we said less than. So if x is less than 0, but not equal to. So right there, that's what we said, less than. And it exists from 0 and all the negative numbers. And then for the second part of our piecewise function, we had 2x minus 1, and we say if x is greater than or equal to, that's what we showed right here, is greater than or equal to 0. And there you go, that's how you write the piecewise function. So pretty easy and straightforward. Now, these step functions, I'm just going to cover what they look like. We're actually not really going to go over them, and you shouldn't have any homework problems on them. If there is, let me know. But this is just what a step function looks like. It just looks like a bunch of lines right here. So we have a line whenever our function is 1, our function is 2, 3, 4, and 5. 1, 2, 3, 4, and 5. And then we go ahead and we state for which x values that our function exists. So right here, for this part right here, for 1, f of x is equal to 1 right here for values between 0 and 2. Well, and then it jumps a step and it goes from y equals 2, but from 2 to 4, and so on and so forth. So that's what a step function looks like. It's just a lot of little pieces of functions, but you can tell that these are constants, so there's no variables in them. So they're just going to be flat lines, flat horizontal lines. So that's a step function. But again, we're not going to really look too much into what step functions are. So here's what I want you guys to do just on your own. I want you guys to write the absolute value function as a piecewise function. So I'll kind of just help you a little bit, but this right here, we talked about it in the other video, in one of our previous videos, that this line right here, that's just the negative f of x is equal to negative x. And then this piece right here is a positive slope, that f of x is equal to x. But what I want you guys to do is to compose that into a piecewise function, and then come to class showing me that you are able to write a piecewise function. So please come prepared to class with that, and any questions that you have, rewatch the video and come with questions, and I'll see you guys in class. Thanks.